Two hands move but never touch. One shows the past. One shows the future. Which is real? Take a moment to think on this. Let the question settle. The world outside seems to run on a steady, even clock. The sun rises and it sets. The seasons turn in their familiar order. We measure our lives in seconds, in minutes, and in years. We trust the numbers on the screen and the hands on the wall. They give us a shared map of our days, a common ground on which we all stand together. Yet, inside your mind, time is a very different thing. It is not a straight line. Your brain, in its quiet and constant work, is a master artist of time. It stretches seconds into long, slow moments. It squeezes hours into what feels like a fleeting breath. The past, the present, and the future are not simple facts. They are constructions, carefully built by the intricate machinery of your mind. This inner world, painted in cosmic blues and shimmering golds of understanding, is where your personal experience of time is born. We will start this journey slowly, and we will look at the simple facts first. Your brain does not have one single central clock. It is not like a watch you can open to see the gears turning. Instead, it has many different ways of telling time, all working at once. Some tiny cells in your brain fire in regular, repeating patterns, like microscopic drummers keeping a steady rhythm. Other parts of your mind mark the passing of time by the number of memories they collect and store. It is a symphony of rhythms, not a solo instrument. It is a complex and beautiful illusion, but it is one that makes our lives make sense. It gives us a sense of order. It allows us to build a story of who we are, where we have been, and where we are going. Without this mental construction, the world would be a chaos of disconnected moments. Your brain is the silent narrator, weaving everything together into a coherent tale. It is a story you live inside every single day. Let's look closer at these clocks inside your head. Let's look closer at these clocks inside your head. They are not made of metal or quartz. They are made of living cells. They are made of electricity. They are made of chemistry. One of the most basic timekeepers is the suprachiasmatic nucleus, a tiny region in your hypothalamus. It is your body's master clock. It responds to the light and dark cycles of the day. It tells you when to feel sleepy. It tells you when to feel awake. This is your circadian rhythm, the deep, ancient pulse tied to the Earth's rotation. It is the foundation upon which your other senses of time are built. But this is only one part of the story. Other brain regions contribute their own sense of timing. Your brain dedicates more processing power to it. It gathers more information, building a richer memory. Later, that density makes the moment feel longer in memory. Attention is like a spotlight that tells memory to record in high definition. This explains a common experience. A day of new, engaging activities, like the first day of a vacation, often feels long in memory. Your brain took in new sights. Your brain took in new sounds. Your brain took in new feelings. A routine workday of familiar tasks can feel like it vanished in a blur. You were not paying close attention because you didn't need to. Your brain formed fewer distinct memories. The day feels short in retrospect. Time, for the mind, is measured not in ticks, but in memories. Emotion is a powerful force. It can change how you see the world, and it can certainly change how you feel time. Think of a moment of sudden surprise or fear. A car skidding on a wet road, a glass slipping from your hand. In these moments, many people report that time seems to slow down dramatically. The world moves in slow motion. You see every detail with impossible clarity. The shattering glass seems to hang in the air for an eternity. The skidding tire seems to take forever to find its grip. This is not magic. It is your brain doing something remarkable. When you are in a state of high alert, a part of your brain called the amygdala kicks into high gear. It flags the event as critical for survival. This emotional arousal triggers a change in how your brain forms memories. Your mind goes into a high-resolution recording mode, capturing an immense amount of detail from the environment. You are not actually perceiving more slowly in the moment itself. Rather, you are creating a much denser memory of it, Later, when your brain plays back this memory, it has far more information to process than a memory of a normal event. The sheer volume of detail makes the event feel as if it stretched out over a longer period. The feeling of time slowing down is a trick of memory, a story your brain tells itself after the fact. It is a survival mechanism. By making frightening events feel longer in retrospect, your brain ensures you learn from them and remember them vividly, helping you avoid similar dangers in the future. The opposite can also be true. Moments of great joy, excitement, deep engagement. A wonderful conversation with a close friend can make hours feel like minutes. The joy of the experience absorbs your attention so completely that you stop monitoring the clock. Your brain does not just live in the past and the present. It is also a powerful prediction machine, constantly trying to guess what will happen next. This forward-looking process is fundamental to almost everything you do. When you catch a ball, your brain predicts its path. When you listen to a sentence, your brain predicts the final word. This constant stream of predictions creates a smooth and seamless experience of reality. You are not just reacting to the world, you are anticipating it. These predictions have a deep connection to your sense of time. When your brain's predictions are correct, when the world unfolds just as you expect it to, moments flow by easily and without notice. Time feels steady and unremarkable. The ticking of a familiar clock, the rhythm of your own footsteps, the flow of a conversation, these things are predictable, and so they blend into the background. Your brain's model of the world is working perfectly, and there is no need to pay special attention. But what happens when something unexpected occurs? A sudden, loud noise. A person saying something completely out of character. In that instant, your brain's predictive model breaks down. It registers a prediction error. This error signal grabs your attention. Your brain pauses its forward momentum to update its model of the world. In this brief pause, this moment of reevaluation, your perception of time can feel altered. The surprise makes the moment stand out. This is why a jump scare in a movie feels so jarring. It is a deliberate violation of your brain's predictions. The filmmaker builds a quiet, predictable scene, lulling your brain into a state of calm anticipation. Then, the sudden sound or image shatters that prediction. Your brain scrambles to make sense of the new information, and in that scramble, the moment is imprinted deeply in your mind. How do we know all of this? Scientists have devised clever ways to study the mind's sense of time. These are not grand, complicated experiments. They are often simple tasks that reveal something profound about how the brain works. In a typical study, a researcher might ask you to estimate how long a light was shown on a screen, or to judge which of two tones lasted longer. By carefully measuring your answers, they can begin to map the quirks and biases of your internal clock. One classic finding is the oddball effect. Imagine you are shown a series of identical images, one after another. Then suddenly a different image appears, the oddball. Even if the oddball is shown for the exact same duration, people report it seemed to last longer. The surprise of the new image captures your attention. That increased attention leads to a richer encoding in memory, which makes the duration feel longer when you reflect on it. Brain imaging technologies like fMRI and EEG allow scientists to watch the brain as it perceives time. These tools can measure blood flow or electrical activity, showing which brain areas become more active during timing tasks. Studies confirm the importance of regions involved in attention, memory, and emotion. They show heightened activity in areas like the insula and anterior cingulate cortex. Both are involved in attention and in emotional awareness, and this links to distortions in time perception. Researchers have also explored how brain chemistry affects time. Drugs that influence neurotransmitters like dopamine can alter time judgment. Conditions that affect dopamine, such as Parkinson's disease, are often associated with timing problems. These findings show our sense of time is not just a psychological curiosity. It is deeply rooted in the physical and chemical workings of our brain. It is as biological as our heartbeat or our breath. Scientists can even see the brain's rhythms interrupted by sharp spikes of activity on an EEG when something surprising happens. There is a special state of mind where time seems to vanish altogether. Athletes call it being in the zone. Musicians call it being in the groove. Psychologists call it flow. It is that state of complete absorption in an activity where you are so focused that everything else fades away. Your sense of self dissolves. Your actions feel effortless and automatic. And the clock, which usually governs our lives, seems to stop ticking. You might work for hours, only to look up and realize that what felt like minutes has passed. Neuroscience offers a glimpse into what happens in the brain during flow. Brain imaging studies suggest that a part of the brain called the prefrontal cortex, which is involved in self-monitoring and critical judgment, becomes less active. This transient hypofrontality means your inner critic goes quiet. Am I doing this right? What will people think? This quieting of the self is what allows for the feeling of effortless action and the loss of self-consciousness. This change in brain activity also explains the altered perception of time. Because you are not checking in with yourself or your surroundings, you are not creating the usual mental markers that help you track the passage of time. The brain's timekeeping systems, which rely on attention and memory of discrete events, are essentially bypassed. You are living in an expanded present moment. The river of time is still flowing, but you are so carried by its current that you no longer notice its movement. Your brain is not a computer in a box. It is intimately connected to your body, and your body has its own set of rhythms that influence your mind. Your heartbeat. Your breathing, the cycles of hunger and fullness, these are all internal clocks. This field of study, known as interoception, explores how the perception of your internal bodily signals shapes your thoughts and emotions. And it turns out, these signals also have a powerful effect on your perception of time. Think about your heartbeat. It is a constant, rhythmic signal sent from your body to your brain. Studies have shown that when people are more aware of their own heartbeat, their timing accuracy can improve. The heart provides a kind of internal metronome. Conversely, when your heart rate increases due to exercise or excitement, each beat becomes a longer unit of subjective time, and so a minute filled with more heartbeats can feel longer than a minute at rest. Your breath is another powerful anchor. The gentle, steady rhythm of inhalation and exhalation is one of the most fundamental cycles of your life. Practices like mindfulness and meditation often begin by focusing on the breath. This is not just for relaxation. By anchoring your attention to this steady, internal rhythm, you can stabilize your mind and change your relationship with time. Many people who meditate report that time seems to slow down and expand. They become more aware of the richness of each moment, rather than rushing on to the next one. This connection between body and mind shows that time perception is not just a cognitive process. It is an embodied one. It is influenced by your physical state, your level of arousal, and your emotional well-being. When your body is calm and in balance, your sense of time tends to feel more stable and grounded. When your body is in a state of stress or agitation, your inner clock can feel erratic and unreliable. To understand your mind's time, you must also listen to the wisdom of your body. We began with a riddle. Two hands move but never touch. One shows the past, one shows the future. Which is real? We have journeyed through the science of the mind and seen that the answer is both and neither. The hands are in your mind. The clock on the wall ticks with an unwavering beat for everyone. But inside you, time is not a fixed measurement. It is a living, breathing experience, painted by attention, shaped by memory, colored by emotion. Your mind is the artist, and time is its masterpiece. This knowledge is not just a curiosity. It is a quiet form of power. It suggests that we are not entirely at the mercy of the rushing clock. By understanding how our minds construct time, we can begin to influence it. You can choose where to place your attention. By immersing yourself in a new experience, the texture of a leaf, the sound of rain, you give your brain new material to work with. You create richer memories. And in doing so, you can make your life feel fuller and longer. We live in a world that prizes speed. Our technology delivers constant novelty, a stream of brief, fragmented moments. This can create a strange paradox. A day can be packed with activity, yet feel empty and short in retrospect. Our brains collect many small, shallow memories, but few deep ones. This may be one reason so many of us feel that time is slipping through our fingers faster than ever before. We are collecting more moments, but experiencing less depth. We are not slaves to the clock. We are storytellers, living inside the narrative our own minds create. The past is a story we retell. The future is a story we imagine. The present is the thin, precious line where the telling happens. If time is a story we tell ourselves, what story will you choose to live?